Fundamental theorem of calculus. I said there is 2 parts to this. The first part was that if I take a derivative of an integral, those are inverse operations, they're undoing each other. And so now, the next part of this is going to be actually how to evaluate an integral. So far we've just done estimates of it with Riemann sums, with our rectangles. So this is going to be a more exact way of getting it. And we are going to do this by saying that the definite integral from a to b, those are my endpoints that I'm wanting to find the area between. All I need to do is take my antiderivative and evaluate it at b, the rightmost endpoint, minus antiderivative at a, the leftmost endpoint. So that's what we're going to work on and practice doing today. It is this one that I need. Yes. All right. So we're going to evaluate the integral. We're going to start let's say from 0 to 3. I should say from 1 to 3. Let's go from 1 to 3. If I use 0, it won't work. All right. Evaluate the integral. So we're going to take the antiderivative here. And I'm going to use these little brackets to show that I'm taking the antiderivative. And I'll take it piece by piece. Antiderivative of 2, well, if I'm undoing the derivative for 2, that original function must have been 2x. Minus 1 over x, as we talked about on Friday, is our derivative of 1 over x. Or is our derivative of natural log. That's the derivative rule for natural log. And we're doing this from 1 to 3. So here's my antiderivative. So now I'm going to plug in 3 into this function minus plug in 1 into this function. So we're going to take plug in 3 minus plug in 1. Plug in 3, I get 2 times 3 minus the natural log of 3. That's plug in 3. Minus plug in 1, and I get 2 times 1 minus the natural log of 1. And so let's evaluate that. 2 times 3 is 6 minus natural log of 3 minus 2, because if I need to have this natural log of 1, but natural log of 1 is just 0. Right, that's asking what exponent do I need to make so that the answer is 1? Well, the exponent to make the answer 1 is 0. Anything to the 0 is 1. So 6 minus natural log of 3 minus 2 equals 4 minus natural log of 3. That's my answer. So plug in at my top minus plug in at the bottom. That's going to be the process. Let's go through another one. We're going from 0 to 1 this time. Antiderivative. For x squared, if the derivative ended up being x squared, the antiderivative, the original, had to have been an x cubed function. And in order to make there be no constant out in front, I must have canceled, which would give me a 1/3. So we have 1/3 x cubed plus, again, work backwards to think about your exponent. Square root of x, that means we have to have, to subtract 1 to get x to the 1/2, that must have started with x to the 3/2. And so since I have to not have the 3/2 out in front, I'm going to put something out in front to make it cancel with it, which is going to be 2/3. Again, we practiced a whole bunch of these on Friday. From 0 to 1. So plug in 1 minus plug in 0. Plug in at 1, that's going to be 1/3 times x cubed, so that's times 1 cubed. Plus 2/3 times 1 to the 3/2. Okay, there's plug in at 1 minus plug in at 0. That's 1/3 times 0 cubed plus 1, 2/3 times 0 to the 3/2. This is about to get a whole lot less messy because 1 cubed is just 1. 2/3 times 1 to the 3/2. 1 to the 3/2 is still 1 times 2/3, so 2/3 minus this whole thing, 0 cubed, 0 to the 3/2, add all that. This whole thing is 0. This is 0 plus 0, which is 0. So 1/3 and 2/3, 1. By the way, if you remember, I had said that when we do these antiderivatives, we needed a plus c constant out in front here. The reason we don't have that here is because if I have a plus c here, it would still be plus a constant, and then I would subtract back that same constant when I went to evaluate the bottom. So I'd have a constant minus a constant, and they would cancel out. So that's why we don't need to write it here. The plus c will come back. Let's go through a couple more together, and then I'll have you try some on your own. Yeah, let's do that much. Okay. From 1 to 32 of x to the negative 6/5. our rule here. X to the negative 6/5, antiderivative. It's going to be from 1 to 32. And I needed to work through what exponent do I need, and what am I going to need on the bottom so that that exponent, there's not a constant in front at the end. So first off, if I subtracted 1 to get to negative 6/5, that must mean the exponent I had up here was a negative 1/5. Negative 1/5 minus 1 to give me negative 6/5. And then, oh, if I take the derivative right now, there's going to be a negative 1/5 hopping out in front. And I don't want a negative 1/5 out in front here. So I need to cancel that out somehow. And the way that I cancel that out, hopefully you can logic your way through it, is negative 5. Because then when I take the derivative, negative 1/5 comes out in front. Negative times a negative is a positive, 1/5 of 5. There we go. This equals, I'm writing it this way because it's going to be easier to plug in the numbers. It's a 5th root of x, and it winds up on the bottom. Plug in 32 minus plug in 1. Plug in 32 minus plug in 1. The 5th root of 32 is going to be 2. Because 2 to the 5th power is going to be 32. It's asking what number to the 5th power gives me 32. What number to the 5th power gives me 1? 1. So that equals negative 5 halves plus 5, which is going to be a positive 5 halves. So for all of these problems, the process you're going to follow is going to be take your antiderivative and plug in at the top minus plug in at the bottom. On the next page of your notes, there should be 3 problems. And I'm going to start tomorrow by very quickly going through those 3 problems. And so what I want you to do, if you're watching at home, is I want you to come into class tomorrow with these 3 problems done and worked out, so that we can take a couple minutes and check our answers on them. So I want you to try those next 3, make sure you know how to do them, and come tomorrow with them solved so that we can go through them, answer any questions, and move forward. So antiderivative, plugging at the top minus plugging at the bottom. That's our process.